I've got another project I'm going to work on, and I'm going to show you something. I have a Nash travel trailer that came with a solar charging system from the factory, and it's a little insufficient. It doesn't have a large panel. I think the panel only supplies 50 or 60 watts. So it's basically just a trickle charger to keep the batteries topped up when we're leaving the trailer in the driveway. And it'll help add a little juice back to the batteries when we're out camping, but it's not really enough for replenishing what we use on a daily basis, running the furnace, running the water pump, running lights, and all that stuff. So the objective here is to replace the ZAMP system, which is this little guy here, with a Renogy system. The charge controller is the Renogy Adventurer. It's a 30 amp charge controller. It's compatible with multiple different battery types, lead acid flooded, AGM, lithium, and so on. So it's a little bit of future proofing too if I want to change the electrical system on this trailer a little bit. So I'm going to show you a few steps here. Basically, the outline of the job is de-energize the solar panel, which I've already done. I've pulled the fuse out of that and put a cover over the panel itself so that at least the wiring from the panel is not providing any voltage. Then I need to remove the existing charge controller, and I'm going to test the new charge controller by just hardwiring it in place without doing the physical installation. That it's going to involve cutting into this cupboard wall and so on. So I want to make sure the charge controller is going to work first before I go carving up the interior of the trailer. More steps to come. As I mentioned, I now need to disconnect the charge controller. It's this set of wires that come through the side of this cabinet. One is the lines that feed the battery, and then the other is the lines that supply voltage from the panel on top of the coach. That's these little, I think they're 10 gauge wires that come down from the roof, and then I've got 8 gauge that goes down to the battery. It's a little backwards in my opinion. It seems like they should have gone from the factory with the 8 gauge wiring on both ends, but this Northwood has not been, in my experience so far with their manufacturing standards, I'd say they're not a really premium coach builder, and they've cheaped out in a lot of places where it's just stupid to do so. So I'm going to rectify some of that, but the wiring is going to stay the same because I don't feel like pulling new wires through the roof and everything. It's a little more involved than necessary, especially given I'm not planning on putting in a very significant set of solar panels up there, so it's not like I really need additional wire gauge to support higher current. I'm now on top of the roof of my trailer. We're looking at the top of the air conditioner housing, and this wood panel is just a cover that I made for the solar panel. It serves two purposes. One is to protect the panel from hail, which we get a lot of here in Colorado, and the other is, for service purposes, to darken the panel and de-energize its output if needed. I just need to reinstall the fuse in this holder to re-energize the circuitry coming out of the panel. I've attached the wiring to the new solar charge controller, so I want to just verify what happens when we feed it some input from this panel. Well, you can see the charge controller is now energized, and you can see a blinking symbol on the left side for the fact that there's no battery connected to the output. And of course the charge controller doesn't like that. It goes into an error condition. But we can see that we're getting good voltage from the panel. We're getting about 19 volts, and that should be more than adequate to run this charge controller and get us some good output. Well, now I've got the charge controller hooked up to both the panel and the battery. You can see that it's charging at 7.2 amps. I'll flip it over for a second just to show you the connections. This Renogy system has a pretty nice set of terminals on it. They're just really simple screw terminals. You push the wires in and run the screw down, and it clamps the wire in place. And it really couldn't get any simpler. It's a lot better than trying to screw around with crimp connectors and things like that. On the front of the unit, there's a couple of buttons. You can kind of go through the menus and look at how many kilowatt hours you've charged for, the amp rate at which you're charging, the current voltage that's being supplied to the batteries. So that's the charging voltage on the output. The temperature, 25°C, that's 25 Celsius, somewhere in between 70 and 80 degrees Fahrenheit. And that's the temperature of the charge controller itself. There is a port on here for an external temperature sensor that you can put down with the batteries. I don't think I'm going to be installing that, partly because the cord for it is only 10 feet, and I'm, with all the run through the ceiling and the wall and down to the battery compartment, I think I'd be well in excess of that 10 feet, and I don't really feel like doing surgery on that cable right now. And frankly, again, because of the simplicity of this setup and the low charging amperage rate that I'll be getting out of it, it's just not really necessary to optimize at that level. So there's that temperature, and I don't know all the menus in this thing yet. I assume that there's some other things that I can mess with, like maybe change it to Fahrenheit. I think I'd have to probably read the manual, and I haven't done that yet. But anyway, the good news is the controller itself is a functioning unit. It's not defective. It's working currently with my batteries and existing solar panel. So that's a start. The next stage is to work on the physical removal of the old charging controller and cutting a hole to install this one flush on the panel. Well, the moment of truth is here. I'm about to cut a big hole in one of the interior panels of the trailer. I made a little template out of some paper and traced the edges of it. There's already some holes here where the old solar charger controller was, so I'll use those as the entry point for the jigsaw blade. And I think I'm going to have to remove this panel to get it out of the way so that my jigsaw base can rest flat against this panel so that I'm not making crappy cuts. Well, I managed to cut the hole and have this controller mounted nice and flush. It's nice and clean there. It made a hell of a mess with sawdust. One thing I did, because of the way these things are made, this is a thin veneer on some cheap wood, and so around the markings where I made the template for the hole, I surrounded that with painter's tape to protect the edges and protect the working surface, from contact with the base of the jigsaw. That kept things in pretty good shape. There's no hole that you're going to cut with a handheld jigsaw is going to come out perfect, and so this one I'm more than happy with how it came out. I think it fits really nice and flush, and it's very feels very secure. I mean, it's a flush and tight enough fit that I probably don't even have to put screws in here, but I probably will anyway, just to complete it and really fully secure it. All right, now we have this all wired in, PV plus and minus for photovoltaic. That's the solar panel input, battery plus and minus, so battery charger output. Nice and clean. Good install. I'm waiting for some more parts, so I'm not going to be able to button this all up yet. I have a Bluetooth controller that's going to hook up to this and be mounted inside here, which will give me app-based access to charging statistics and configuration and other stuff. I'll show that install in a separate video.